Hello everyone, welcome to the Sparkplace Guide to MeshCam V7 and the Carbide Nomad 883 CNC milling machine. Today we are going to discuss the basics of setting up your file, correctly loading your material, and then setting up the machine for your job. First, we are going to open up MeshCam V7. This software is what generates the code that controls our CNC machine. On the left side is the main toolbar. At the moment, it is currently empty, but once we load a file, we'll be able to see quite a few more options. To load a file, click Open File and load your file of choice. In this example, I will be loading an STL file of a pawn chess piece. Once you select your file, you should see it appear in the center of the screen. To rotate around your model, left-click and drag. To change the model's position, right-click and drag. To zoom in and out, scroll the mouse wheel. Note that the main toolbar on the left-hand side of the screen has changed. At the top left is Select Side to Machine. These options will allow us to change the orientation of our 3D object. For this particular job, we will be using the front orientation. However, some jobs may require you to use different orientations. Next is File Units. This section is used to describe what units of measurement were used during the creation of this 3D object. It is important to confirm the correct size of your object in the Geometry Size section. Then move on to Project Units, which describes which unit type we will be using during this project. For most of our jobs, we suggest inches, due to most of our resources using that as their unit of measurement. Once finished in this section, please click OK. Once again, the main toolbar on the left side has changed. This screen is where we'll be doing most of the work from here on out. But first, we have to select what job type we are doing. Click on the Setup tab, and then click Set Job Type. After this, the software will prompt you with two different selections. The 3-axis job is used for jobs that will only be milled from the top down, while Flip Job allows you to machine the top and bottom of your material in 2 separate passes. For this example, I will be using a Flip Job. Note that there are 2 sets of axes on this model now, one at the top and one below the model. The red arrow indicates the x-axis, also called the width. The green represents the y, or the length, and blue represents the z, or height. Now we will head to the Parts Setup area. Here, we adjust some of the basic info about our design. If you click on Parts Setup, a pop-up will appear, telling you some basic geometric properties of the piece. Below that, you can choose to rotate or scale your object, as well as see the previously mentioned geometric properties. Then, we can select our material. There are quite a variety of options, but if you don't see your specific material, please pick one that most closely resembles it. Stock is our next option, and here we can define the dimensions of the material that we will be cutting. If we click on one of the drop-downs, we can see 3 options. Fit to Geometry means that our stock is exactly the same dimensions as our 3D object. Fixed Size will allow us to type in specific dimensions of the stock, while Geometry plus Margin uses our 3D object as a reference, then allows you to set the amount of stock around the geometry. It is extremely important to use as exact a measurement as possible when measuring your stock. Note that after the stock size is inputted, a red box appears around your object. This represents our stock visually. Make sure to rotate fully around your 3D object within the stock. If your 3D object does not fit within the stock, consider resizing it, or else you may encounter problems later on. After defining our stock size, we will set the program 0. This defines the reference point that the machine will use. For the Z position, you can choose between the top, middle, and bottom of the stock. For the XY position, please choose between one of the 9 locations on the example stock below. For this example, I'm choosing the center top of my stock as my 0 position. Make sure to verify that the axes have moved to the correct position over the stock. Next, we will set our max cutting depth. This step determines how deep into our material we will cut. When doing a two-sided object, this step will determine its cut depth on both sides. For this project, we will go slightly beyond the midpoint to 0.375 per side. Make sure to rotate your model and check that there are two red lines going through the center of your design. Now we move on to the machine regions. Clicking on machine regions will bring you to a top-down view of your object. Here, you use these basic shapes to designate areas that you want machined out or avoided. The top row creates areas that can be machined in the stock, while the bottom row creates areas that will be avoided during the milling process. To place a milling region, simply left-click with your mouse in the area you would like the region to start, and then left-click again in the area you would like it to finish. It is important to leave a bit of stock on all sides, so that the stock does not break during the milling process. Next, I will add some keep-out regions around the corners of this object, in an attempt to save time during the milling process. Make sure not to get too close to the model when making these keep-out regions. Failing to do so can cause a problem where the end mill cannot fit between the model and the keep-out region, thus preventing your job from finishing. Finally, we move on to geometry supports. These are small support structures that connect your 3D model to the surrounding stock. These supports will have to be removed after the model is finished milling, but it prevents your object from coming loose during the cutting process. For this pawn, we will use a 1/4-inch support placed in the center of the model geometry. To place the support, simply left-click in the area you would like it to go. If you want to remove a support, right-click on the support. Multiple supports can be added in different places, but for this job, one should be enough. As always, make sure to rotate your 3D design once you are finished with this step, to make sure that everything is in its correct position. After all of that, we are ready to move on to the job setup section. Make sure that job setup has the correct job type listed next to it. Then confirm that the correct machine is selected. For our job, we'll select Carbide 3D Nomad Pro. Next, we determine our tolerances. The lower the tolerance, the finer the detail, but also the more time the job will take. Next up, we have Area to Machine. Under Area to Machine, we have two options, Machine Whole Stock and Machine Geometry Only. Both will be affected by our previous machine regions, but Machine Geometry Only will add an additional constriction. This setting will allow you to set a boundary a specific distance away from the edge of your 3D object. For our example, the distance around the geometry will be set to 0.2 inches. We are now finally ready to create our own toolpaths. Click on the Create Toolpaths button. This will open up a new window, which will attempt to determine what type of toolpath we are trying to create. There are 4 options here, but for today, we will just worry about the Freeform/3D toolpath. Next, we will select the tool. For now, there is only one tool available, but there will be many more in the near future. Lastly, we get to the pathing window, which has 2 tabs, Parallel Rough and Finish. Here, we can adjust the specific settings for the job we are running. For this job, we need to change the feeds and speeds. Feed rate is the speed at which the tool will move through the material on the XY plane. Plunge rate is the speed at which the bit will move into your material in the Z axis. And RPM is the rotations per minute, or how fast the cutting bit is rotating. I would recommend referring to the feeds and speeds chart posted by the machines for these specific settings, but some jobs will require you to do research into what feeds and speeds are right for your material. After this are the cutting parameters. Step over is how much overlap your bit will have between passes. A general rule for step over is to make it around 50% of your tool size for a roughing pass and less than 20% for your finishing pass. Step down is how far down your bit will move after each pass. Lastly, there is the options section. Stock to leave determines how much stock is left over before your finishing passes. Less stock to leave means less time spent finishing, but going too far may have negative results in your final piece. 3D roughing removes excess material that would be too difficult for the machine to cut in one go during your finishing step, while contour offset follows the shape of your design with each pass, rather than using parallel lines along the x-axis to cut out your shape. As a general rule, contour offset will take longer to calculate than the standard method, so we will skip it for today. Make sure to adjust your feeds and speeds in the Finishing tab, then move down to the Options section. Since we are doing a 3D model, we want to select the 3D finish, and because we have a roughing pass set, we don't have to worry about machining the top of the stock. Finally, there is the threshold angle, which determines the angle at which the machine needs to cut away before the finishing cuts are applied. The software will now create toolpaths using the settings we've provided. Make sure to rotate the camera around and examine the green lines following the contours of your design. These are the toolpaths that will be cutting out your shape, and it is important to make sure that they look correct. The red lines represent the rapid travels above the stock, which the machine uses to move quickly to different areas. The blue lines are the downward steps a bit will take at the start of each pass. Then, take a look at the estimated times over on the left-hand side. These give you a rough idea of how long this project is going to take, but be aware that they may take longer than this projected time. Finally, click Save All, and then save your designs as a .nc file. If you are doing a flip job, make sure that you save both of your files with separate names. Setting up the machine is a rather simple process. First, we will add spacers between the jaws of the vise. These will help protect the jaws in the event of an error. Next, we place our stock between the spacers. Note the center location that has been marked for later convenience. Slide the jaws of the vise together, then tighten both down. Make sure that these are tightened snugly and not overly tightened. We will now tighten down the screw on the left side of the vise. This will lock down the stock, preventing it from moving during the milling process. After tightening the screw, it is a good idea to test the stock by gently pulling on it and seeing if there is any movement. Next, we need to make sure that the correct bit is loaded in our machine. To change the bit, take two wrenches located next to the machine. One goes above the chuck, and the other is placed on the chuck itself. Turn the wrenches counterclockwise until the chuck loosens up and can be turned by hand. Remove the end mill and replace with the correct end mill for your job. Reattach the chuck, then tighten snugly. Do not over-tighten, or you may damage the machine. After completing this process, you may turn on the machine by pressing the button at the very front. Now we move back to the computer and open up Carbide Motion. This is the software that controls the operation of our CNC machine. When prompted, click Connect Cutter, which will connect you to the machine. Next, click on the jog button, and then click to begin homing. After the machine homes itself, it will then prompt us to measure the tool that is currently in the machine. We will be placing the tip of the end mill on top of the central point of the stock. To move the mill, use the cardinal direction buttons. Y positive and negative will move the bed forwards and backwards. X positive and negative will move the mill side to side, and Z positive and negative will raise and lower the end of the mill. Take your time and slowly move the bit to the marked location on your stock. Take this process slowly, as you want to be as accurate as possible and don't want to either damage your stock or the machine. Once you get close to the correct position, you will slide a piece of paper under the end mill and lower the move increment to 0.1, and then slowly lower the end mill down. Gently slide the paper back and forth between your stock and the end mill until you start to feel tension from the bit. Once you have moved to the 0 position, click Set 0 and 0 all 3 axes. After clicking Done, it is highly suggested to double check that your zeros have actually been saved. We are now officially ready to start our job. Make sure that the machine is clear of any and all obstructions, and inform a SparkPlace employee that you are ready to run the mill. They will give you the all clear, and then you can click Load and load your first file. When you are ready, click Run, and then click the Play button. The machine will prompt you to change the bit, but as we've already done so, we can ignore this step. Afterwards, it will rehome itself and then begin cutting. Make sure that you stay by the machine during the cutting process. In the event of a problem, the glowing blue button at the front of the machine acts as an emergency shutoff button. Make sure to hit this button in the event of a serious problem. We will check back on this machine once it finishes cutting this side. Once the machine finishes, the piece will slide forward and the mill will stop moving. Clean off your material with a vacuum located beneath the machine. Use a hex wrench to loosen up the jaws and remove your piece. If you are doing a flip job, make sure to rotate your piece laterally and place it back in the clamp's jaws, then re-tighten. Be sure to verify your 0 position again, and then load your second file and click Run. Once it finishes, vacuum out the mill and remove your finished piece. There are tools in the space that can help you remove any supports that may need to be removed. Thank you for watching our tutorial on MeshCam V7 and the Carbide Nomad 883 milling machine. If you have any questions, feel free to contact us at sparkplacegcpl.lib.oh.us or give us a call at 937-736-7092.